In the name of Allah, the entirely merciful, the especially merciful. Dear third grade students at the Faculty of Commerce at Banha University, this is our second recorded lecture of the course of Statistical Forecasting Techniques. So pay attention and let's start. As we said before, the graphical presentation is a very important task to make any analysis. If anyone which is not specialized and he wanted to know any trends in data, he will see the graphical presentation. If it is time plot, seasonal plot, or scatter plot. A seasonal plot is similar to a time plot, except that the data are plotted against the individual seasons in which the data were observed. Okay? This is something like a time plot, except that the data from each season are overlaid. A seasonal plot enables the underlying seasonal pattern to be seen more clearly and also allows any substantial departure from the seasonal pattern to be easily identified. For example, as we see in this data, it is antibiotic drug sales. It's clear that there is a large jump in sales in January each year, as we observed. Actually, these are probably sales in late December, as customers want to take antibiotic because in winter there is very cold weather and many people can get a flu disease or virus. So as we see in the January and in the December, which is winter season, there is some high fluctuations, which said that there is big sales in these seasons. So graphical presentation can visualize the data, so anyone which is not specialized in this data can see the fluctuations in data and see outliers, which means that there is strange points go away from data. The graph also shows that there was an unusual small number of sales in March 2008. Most other years shown an increase between February and March. The small number of sales in June 2008 is probably due to incomplete counting of sales at the time the data were collected, or I can interpret it because of summer season. There was many factors that make people don't buy the antibiotic drug. After explaining the time plot and seasonal plot, which is specialized in seasons can be weekly, can be a monthly, can be quarterly, which is every 3 months, can be monthly, okay, So we will turn to scatter plot. If we have car data, it is not a time series, making time or seasonal plot inappropriate for these data. However, these data are well suited to a scatter plot. So the time not a variable or not affect on this data, such as that of price against mileage. Mileage is a number of miles. In the following figure, we have plotted the variable we wish to forecast. So there is two variables, the variable wish to forecast and the explanatory variable. The variable we wish to forecast is a price against one of the explanatory variables, which is mileage. Each point on the graph represents one type of vehicles or one type of cars. The plot shows the relationship between price and mileage. So when we look at here on this data, there is two variables. One is price and the other is mileage, and time is not here because it's not affect on these two data. As we notice here, every point in this graph represents a type of vehicle or a type of car. There's two variables. The first one is mileage, which is explanatory variable, which is explain the change in the other variable, which is price. It is in the x-axis, but price is on the y-axis, and it changed according to mileage. It is the variable which we wish to forecast. So this graph is a scatter plot of price versus mileage for car data. There are 45 car, and every point here represents every car. Now we will move to the basics steps in a forecasting task. The first step is problem definition. Often this is the most difficult part of forecasting. Defining the problem carefully requires an understanding of the way the forecasts will be used. Who requires the forecasts, and how the forecasting function fits within the organization requiring the forecast. A forecaster needs to spend time talking to everyone who will be involved in collecting data, maintaining databases, and using the forecasts for future planning. It is the most difficult part of forecasting. This step is the most part of forecasting because it requires understanding and defining many concepts, and I already explained this part, but you should know the name of the basic steps in forecasting task. You should save it in your mind, and then you should understand what is in the every point. Okay, let's turn to the second step. The second step is gathering information. We know that information is very important in forecasting. As we said before in the first lecture, there's steps or there is conditions for forecasting. The first one, as we know, information about past is available. Number two, this information can be quantified in numerical and in numeric numbers. Number three, past pattern will be continued in future. So this step is important. As we know, there are always at least two kinds of information required. The first one is statistical data. The second one is the accumulated expertise of the people who collect the data and use the forecasts. Often, it will be difficult to obtain enough historical data to be able to fit a good statistical model. However, occasionally very old data will be less useful due to changes in the system being forecast. For example, if we want to know the forecast of a particular institution or a particular factory, we should know the production of past years, but know the old data or the very old data. If we want to know the production of 22 or forecast at 2022, we shouldn't know the production of this factory in for example 1960. This data will be less useful due to changes in the system of being forecasted. Okay? By turning to the third step, which is preliminary or explanatory analysis. Always start by graphing the data. As we know, the first thing we do in the forecasting problem is presenting data or plotting it, graphing it. So there's some questions in our mind. Are there consistent patterns? Is there a significant trend? Is seasonality important? Is there evidence of the presence of business cycles? Are there any outliers? And we know what outliers mean. Outliers is extreme points, is strange points. If our mean or our median is 5 when we make or when we order the data from 1 to 10, so the median is 5. Here, if there's outlier, we can see in this data 100 is outlier. Okay, so is there evidence of the presence of business cycles? Are there any outliers in the data that need to be explained by those with expert knowledge? When there is outlier in a data, the expertise or the expert person should explain why these outliers in the data, present in the data. How strong are the relationships among the variables available for analysis? And we know the relationships, what mean by it. Various tools have been developed to help with this analysis. The first step is choosing and fitting models, and this point or this step come after the problem definition, gathering information, exploratory analysis. Finally, this point come after these points. The best model to use depends on the availability of historical data. We know there are conditions of forecasting. One of them is the availability of the past data, of the historical data. Okay? The strength of relationships between the forecast variable and any explanatory variable, and the way the forecasts are to be used. So we should know the best model depends on what? Depend on availability of historical data, depend on the strength of relationships between variables, and finally depend on the way the forecasts are to be used. It's important point. It is common to compare 2 or 3 potential models. We can compare more than one model. Each model is itself an artificial construct that is based on a set of assumptions and usually involves one or more parameters which must be fitted using the known historical data. So this point summary is we should know the factors that affect on the best model. The final step is using and evaluating a forecasting model. Once a model has been selected and its parameters estimated, the model is used to make forecasts. The performance of the model can only be properly evaluated after the data for the forecast period have become available. A number of methods have been developed to help in assessing the accuracy of forecasts. The important point here is we want to know the methods that assess the accuracy. There are also organizational issues in using and acting on the forecasts. So, the summary of this point, or the summary of this step, we want to use or to evaluate a model of forecasting by evaluating the period with available and assessing the accuracy of this model. We will turn to the important statistical tools used for forecasting. In forecasting, we should use some tools or some statistical tools. In descriptive statistics and in applied statistics course, in the first year and the second year, we take these tools, but we will revise and we will refresh our minds by knowing them again, because we will use them during the course. As we know, there is univariate data and there is bivariate data. Univariate mean single data or single variable, okay, or single data set. bivariate means there are two variables, one affect on the other. Multivariate data, there are more one variable in this data. Firstly, univariate data. For a single data set or for a univariate data or a single time series, the most common descriptive statistics are the mean and the standard deviation, finally, and the variance. To summarize, suppose there are n observations and the individual observations are denoted by yi for I from 1 to n. Then the univariate statistics or summary numbers that will be used in this text are defined as follows. As we take in the past years, there are measures of central tendency. These measures are mean, mode, median, and many measures that we take. The first one is the mean. The mean or y bar equal summation of the observations in a data, and we will divide them over the number of them, okay, or total number of them, n, which is equal to the total number of observation. So in any mean we have numerator and the denominator. The numerator is or have summation, okay, and the denominator have the total number of observation. Median is the, it depends on how is data set odd or even. If it is odd, it is the middle observation, but if it is even, it's the average of middle two observation, okay. So and mode is the most frequent one, the most frequent observation in the data, but we will not use it in the course, so we didn't write it. But when we will move to the measures of variation, firstly, mean absolute deviation, M for mean, A for absolute, D for deviation. When we explain what is mean by the mean, we say that any mean is equal to the sum of observations, or what we wanted to measure, over the number of observations. So when we wanted to make a definition for mean absolute deviation, we write it the summation, we put the sign of summation, and we in the denominator we write n. When we say absolute, the absolute sign is here, and it is mean that minus or positive here is the same. So mean absolute deviation had this formula, but we didn't explain the deviation. Deviation means that how this point deviates from the mean. how yi deviate or far from the mean. So we will turn to the mean squared deviation. M for mean, S for squared, D for deviation. Mean squared deviation, by its name, mean is equal to summation over n. Squared, we square the deviation. Deviation means how far this points from its mean. Variance is the same of the mean squared deviation, but it is divided on n minus 1 by because of a statistical purpose. And the standard deviation is the square root of the variance. All summations here are over the index I from 1 to n. Okay. I'll explain median because some students after the face-to-face lecture want to explain this point again. So we know the data may be odd and may be even. If the data is odd, for مثلا 1 3 5 7 9, these data are equal in number of observation here equal, or in here equal to 5. So the median here, or the median place here, is n plus 1, which is equal 5 plus 1 equals 6 over 2. So the place here is the third place. The third place is the median place, which here equal to 5. It is the third place. But if the data set are is even, here the data set or n equal 4, the median place will be equal to n over 2, which is equal 4 over 2 equal second place, plus n over 2 plus 1, which is equal to the third place. The second place and the third place, we take the mean of them, which is equal to 3 plus 5 equal 8 over 2, which is equal to 4. So the median is the observation which is divides the data into two equal data sets. Let's turn to this example. Example 1.1. Consider the mileage, which is the number of miles of the 19 Japanese cars given in the following table. The vehicles have been numbered from 1 to 19 for easy reference. And instead of saying Mazda or Nissan or Mitsubishi, we said vehicle number 1 or car number 1, car number 2, and car number 19. Firstly we should know and we should remind our important statistical tools that we said before. Firstly, the median is the 10th place, because here the data is odd, which is equal to 19 observation. So the median here is in the 10th place. Okay. Firstly, but don't forget to order the data from the least number to the highest number. After ordering them, we will find the median, which is the 10th place, and it is equal to 23. Second important, we wanted to know the mean. The mean, or y bar, is equal to summation of yi over n. Summation of yi means that summation of this mileage, 19 plus 19 plus 22 plus 2, 35. So we said summation of yi from 1 to 19 or to n. Here mean is equal to 469 over 19. Okay, we will turn to the measures of variation, which is mean absolute deviation, and mean square deviation, variance, and finally standard deviation. After obtaining median and mean, we will make a table. The first column is vehicles from 1 to 19. The second one is mileage, or number of miles, and write the numbers of it. Third column is the deviation, which means how far every observation from its mean. The first column will be the absolute value of this deviation. To find the mean absolute deviation, and we said the mean absolute deviation, we firstly write summation over n. Secondly, we take the deviation of we take the absolute deviation of the deviation, and finally we obtain the mean absolute deviation, which is equal to the column, the sum of the column 4 over n, and n, we said it before, n is 19 cars, or the total number of observation, which is 19. Mean square deviation. Mean square deviation is the column 5, which is the square of the deviation after obtaining the mean, or the square of this deviation. We take the mean of this column, and we take the sum of this column, and we divide it over n, which is equal to 19, and finally finding mean square deviation. Variance, it is the same of the fifth column, but it is over on n minus 1. It is divided by n minus 1, not n. Standard deviation is the square root of the variance. Moving to this point, which is bivariate data. For a pair of random variables, bivariate data, it is of interest to describe how the two datasets relate to each other. The most widely used summary numbers, or statistics, for this purpose are the covariance and the correlation. They are vital statistics for bivariate datasets. So we will save in our mind these two formulas. The first one is for covariance, which is equal to summation of xi minus x bar multiplied by yi minus y bar, or the second variable. All of these are divided on n minus 1, and the correlation formula equal to the covariance of x and y divided by sx multiplied by sy. And we know that sx is the standard deviation of x and sy is the standard deviation of y.